Hey everyone, and welcome to your super fast review for the Math 120 second midterm. We're going to skip the fluff and get right into the most important problems and strategies you absolutely need to know. Let's do this! So here's our game plan. We're going to hit the big 5 topics, starting with limits and going all the way to absolute extrema. Then we'll wrap up with some really quick tips. Trust me, this covers the main types of problems you're almost guaranteed to see on the exam. First up, limits and continuity. You know, this is classic question 1 territory on any calculus exam. The whole game here is knowing when to prove a limit exists, and maybe more importantly, how to prove that it doesn't.
So this is the question they're going to ask you, right? Does the limit exist? Your job is to have a clear plan. So how do you decide what to do? Well, it all boils down to 2 main strategies.
Okay, this is absolutely key. You have to know which tool to use. If you have a feeling the limit is probably 0, especially with sines or cosines involved, the squeeze theorem is going to be your best friend. But if you're skeptical, if it looks kind of weird, the path test is your weapon of choice to prove it doesn't exist. So, if you're going with the path test, here's your playbook. Always start simple. Try the x-axis, so y equals 0. Then try the y-axis, x equals 0. If you get the same answer, don't give up. Try a general line, y equals m. If the m sticks around in your answer, that's great. It means the limit depends on the path. If not, a parabola, like y equals kx squared, is a really common next move. Remember, all you need is 2 different answers, and you win.
And check this out, a perfect example from an old exam. Coming in along the x-axis gives you a limit of 0. But when you approach along the parabola y equals x squared, you get a completely different answer, 1/2. Since 0 is obviously not 1/2, you are done. The limit does not exist. That's it. Move on to the next question.
Okay, next up, let's talk derivatives. You're for sure going to be calculating partial derivatives, but let's focus on a trick that will save you a ton of time and effort, implicit differentiation. You have to memorize this formula. Seriously, it's a lifesaver. When they give you some big, messy equation with x, y, and z all mixed up and ask for, say, partial z partial x, this is your shortcut. Instead of a complicated chain rule, you just find a few simple partials of your main function f. And look at how cleanly this works in an actual exam question. In question 5a, you just define your capital F function, find its partial with respect to x, find its partial with respect to z, and then just stick them in the formula with a minus sign. Bam! There's your answer. It's so much faster.
On to tangent planes. This is another classic you can pretty much count on seeing. And what's the secret here? It's all about the gradient vector.
This is the formula you need. But the big idea, the thing you have to remember, is that the gradient of your surface, that delta f, when you plug in a point, it gives you the normal vector. It's the vector that sticks straight out, perpendicular to the surface at that exact spot. And once you have a normal vector and a point, writing the equation of the plane is easy.
And here it is in that same exact problem. You calculate the gradient of f, then you plug in the point they give you, 1, 1, 1. That spits out your normal vector, which here is 3, 3, 5. From there, you just pop it straight into the plane equation formula, and you're golden.
All right, let's get into finding and classifying local extrema. This is a guaranteed question. There's no way you're not getting one of these. And it's all about following the steps for the second derivative test, which you know as the D test. You've got to know this procedure inside and out. This workflow is everything. Do not skip a single step. Step 1, find your critical points. Set both partial derivatives to 0 and solve that system of equations. Step 2, calculate all your second partials and compute the discriminant, d. Then, the final step, take each critical point you found, plug it into d, and use the signs to classify it as a min, max, or saddle.
And here is a perfect walkthrough of the process. In this question, they solve for the gradient equals 0, and they find 2 critical points. For the first one, 0, 0, d comes out negative. Easy, that's a saddle point. For the second one, 1, 2, d is positive, which means it's either a min or a max. So you check the sign of fxx, it's positive, so it's a local minimum. Just follow the steps.
Okay, deep breaths everyone. This is the big one. Finding absolute maximum and minimum values on a closed region. This is often the longest, multi-part, high-point question on the midterm, so let's make sure we know how to handle it.
I cannot say this enough. Before you even think about taking a derivative, you have to draw the region. Seriously, a good sketch is half the battle.
Label your corners, understand your boundary curves. A good picture will make the whole rest of the problem so much easier.
So, what's the strategy? It's a three-part attack. First, you check for critical points on the inside of the region, just like you did for local extrema. Second, and this is the long part, you have to tackle the boundary, one piece at a time. This is where you basically turn it into a Calc 1 problem for each edge. And third, don't forget the corners. Finally, you make a big list of all your candidate points from all three steps, plug them all back into the original function, and just find the biggest and smallest values.
All right, we are in the home stretch. Let's finish up with some rapid-fire tips. These are the key ideas you should just be chanting to yourself as you walk into the exam room.
Seriously, remember this stuff. The gradient tells you the fastest way up the hill. It's always normal to your level curves. That's why tangent planes work. And please, 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 don't be that person who finds all the inside points but forgets to check the boundary on the absolute extrema problem. It's such a common place to lose points. And of course, double-check your algebra. A simple sign error when you're finding critical points can derail the whole problem.
And that's it. That's our high-speed run-through of the core stuff for midterm 2. Look, you've seen the main problem types, you know the strategies now, you've put in the hours studying, so walk into that exam with some confidence. You are ready for this. Okay, good luck on your Math 120 midterm. You've totally got this.